Hello mathematicians, and welcome to day 2 of solving. And now, instead of factored form, we're going to be solving by factoring. So I'm going to go ahead and do the first one as a review. You can go ahead and skip through the video if you don't need it, but we're trying to solve by factoring, and we have this factored form equation. It is factored form when there are two parentheses like so, or two sets of parentheses. So again, I'm trying to figure out what's going to make this equal to 0. There's two ways to do this. The first one is you take each one individually. So x minus 1 equals to 0. And you get rid of the negative 1. So I'm going to go plus 1, plus 1. This crosses out. So I get x equals 1 as my first answer. I have to do the second thing with the second binomial. So minus 4, I need to get rid of it. I'm going to go plus 4 on both sides. Negative 4 plus 4 is 0. I'm left with my x on one side, and on the other side I have 0 plus 4, which is a 4. Now, another way we can look at this is right here I see that I have a negative 1, and this became a positive 1. So if you notice, when we have factored form, I'm going to write this on my notes. With factored form, we can easily just flip the signs. So the same thing here. Right here I have a negative 4, and my answer became a positive 4. So my roots would be x equals 1, comma 4. And again, you can draw it over here. I'm going to make some guesstimates. I'm going to say that 1 is like right here. So that's 1, 2, 3, and 4 is right here. So it's probably going to look something like this. It doesn't really matter. Well, the only thing that matters is where those points are. So let's go ahead and try a little hack with the second problem. Right here I have a negative 1. So I know that one of my answers is going to be a positive 1. So you could put positive right here, or you can just leave it as 1. It doesn't matter. Right here I have a positive 4. So this is going to turn into a negative 4. So my answer over here would be 1. So I'd be right here. 1, negative 1, negative 2, negative 3, and negative 4. So this one's going to look something like this instead. But what happens when we don't have this factored form? So let's look at problem 3. Problem 3 is a problem because this is not factored form. Not factored form. This is a trinomial. This is a trinomial. If that sounds familiar, it's because you learned it when we were talking about polynomials. So what can we do here? To be honest, if we were to set this equal to 0, there's no way you can move this around to get x by itself. It's not possible. I've tried it. You can knock yourself out. But something that we learned with polynomials is that you can use factoring. Because with factoring, we get factored form. So let's recap. With factoring, there was the x method. And you learned the GCF method. You're probably groaning right now, but yes, this is coming back to haunt you. Now I'm going to write some cheat notes right here. And I'm going to say that with the x method, you usually use it when there's 3 terms. So if I see a polynomial that has 3 terms, I automatically check for the x method. The GCF, it works for any of them, so it's kind of winky. So let's go ahead and treat this. We're not going to set it equal to 0. We're just going to treat this as a polynomial. And I want to get it to factored form. So my goal is to make it look like this. Because when we have it like this, we can use our cheat of just flipping the signs. Okay. So I'm going to use an x method. I'm going to create my x. Then I'm trying to find two numbers that multiply to 4, which is this last term right here, but that they add up to my middle term, which also happens to be 4 in this case. So you can make a list on the side. I know that 4 is 1 times 4 and 2 times 2. If I add up 1 and 4, that gives me 5, so that is not it. But I know that 2 and 2, if I add them up, that they give me 4. So 2 and 2 right here. So that means my polynomial is going to be an x and an x right here. And I'm going to put plus 2 and plus 2 right here. So what do you think my answer is? Remember, we can just take our number right here and flip the sign. So the first one's going to be negative 2. And my second one's going to be also negative 2. Oops, negative 2, comma, negative 2. But you guys notice how those are just technically the same answer, right? Well, we only have to write it once because it's just repeating itself. We don't have to write any extra, right? So you're probably saying, how does that one look? So again, on my x-axis, if I go negative 1, negative 2, that means that my parabola looks something like this, where it's barely touching the puntita, okay? So let's go ahead and try out number 4. So, I do not have factored form here. This is a trinomial. So I'm going to try using the x method because I have 3 terms. 1, 2, 3, okay? So I'm going to do my x right here. My last term goes at the top, so negative 6. My middle term, which is an imaginary 1 right here, goes at the bottom. So I'm going to go negative 6. I know that 1 times 6 gives me 6, and 3 times 2 gives me 6. But I also know that since this is negative right here, that means that one of these has to be negative. So I'm going to do this side. So 1 minus 6 gives me negative 5, so that's not it. 3 minus 2 gives me 1, so this has to be my solution right here. 3 and negative 2. So if I were to write this out as my polynomial, this becomes x plus 3 and x minus 2. Now I'm trying to figure out what the heck makes this equal to 0. You can use algebra or you can just use our little cheat sheet. This is plus 3. So that means that one of my answers has to be negative 3. This is negative 2. So that means that my other answer has to be a positive 2. So if I were to draw this out, 1, 2, there's my first one. Negative 1, negative 2, negative 3, and there's my second one. Bam. And there you go. I'll see you for the next